Hello everyone. In this video, what we're going to be doing is the 2019 AP Calculus AB and BC. This appeared on both the AB and the BC exams. Question number 1. Okay, so fish question. So let's read the question. Fish enter a lake at a rate modeled by the function e, given by e of t equals 20 plus 15 sine of pi t over 6. Fish leave the lake at a rate modeled by the function L, given by L of t equals 4 plus 2 times 0.1 t squared. Both E of t and L of t are measured in fish per hour, and t is measured in hours since midnight, t equals 0. So part A. How many fish enter the lake over the 5-hour period from midnight, t equals 0, to 5 a.m., t equals 5. Give your answer to the nearest whole number. So what we have to do, so we're just talking about fish entering a lake. So we have to take the integral from 0 to 5 of e of t. So 20 plus 15 sine of pi t over 6 dt. Okay? And what do we get as a result? So 20 plus 15 sine of pi t over 6 t from 0 to 5. We got about 153 fish. 153 fish. And that is what we get over here. So part B, what is the average number of fish that leave the lake per hour over the 5-hour period from midnight, t equals 0, to 5 a.m., t equals 5? So we're now talking about not entering, but leaving the lake. So we have to look at L. The average number of fish. So that is from 0 to 5, 1 over 5, okay, times the integral of from 0 to 5 of L of t. L of t, 4 plus 2 to the 0.1 t squared power, okay? And we integrate that with respect to t. So what do we get as a result? Well, we get 1 over 5 times the integral of 4 plus 2 to the 0.1 t squared. T squared with respect to t from 0 to 5. And we get an answer of 6. Okay, and we get an answer of 6.059. 6.059. Okay, it's approximately 6 fish per hour. Okay, so about 6 fish per hour. That's the average rate of change, the average number of fish that leave the lake per hour. Okay, so part C. At what time t for 0 is less than t is less than 8, well actually less than or equal to, is the greatest number of fish in the lake. So what we have to do is factor in the total rate. So what we're going to do is define a function r of t, this total rate of change of fish from the lake, to be e of t minus L of t. And if we solve this for 0, okay, this total rate has to equal 0. That means e of t must be equal to L of t at some point t. And at that point, we can see if it's the greatest number. Okay? So what we have to do is see where 20 plus 15 sine of pi t over 6 equals 4 plus 2 to the 0.1 t squared, where at what time t are those two expressions equal? And now this is where we plug in to the graphing calculator. Okay, sine of pi t over 6 minus 0.1 t squared. And what do we get as a result? Just trying to graph it. Give it some time. Okay, so find the 0 over here. If we get t is equal to 6.20356. And if I'm looking at the graph right now on my graphing calculator, it doesn't really intersect anywhere. Okay? It doesn't intersect anywhere from 0 to 8. Now, r of t is greater than 0. In fact, it is greater than 0 for 0 is less than or equal to t, it's less than 6.20356, and r of t is less than 0. For 0 is less than t. Well, not 0, than t is greater. 356 is less than t. It's less than or equal to 8. So it sort of looks like this. Okay, so our x-axis, that's our y-axis. It sort of looks like this. So it has one relative max. Okay? And we know that this is the absolute maximum. This has to be our absolute maximum. Because if 0 was our absolute maximum, well, it's increasing after that. So that certainly cannot be our absolute maximum. It cannot be 8 either. Okay, they're asking, it's a closed interval, so we're factoring in 0 and 8. They don't give the number of fish, but you can do some pretty quick reasoning that it can't be 0 or 8. Because after this maximum point, the derivative starts to decrease. It becomes negative. The function starts to decrease. So at time t equals 6.20356, you have the greatest number of fish in the lake. Okay. Now, is the rate of change in the number of fish in the lake increasing or decreasing at 5 a.m.? So is the rate of change increasing or decreasing? Okay, so the rate of change, the total rate of change, is it increasing or decreasing? That we can find out by r prime of t. Okay, is the rate increasing or decreasing? So that is basically e prime of t minus L prime of t. And rather than taking the derivative, I already have the graph set over here. So what we have to do is find the derivatives at x equals 5. And the derivative, according to my calculator, at x equals 5 is equal to negative 10.7228. That means the rate is decreasing. Is less than 0, so it is decreasing. So the rate R is decreasing. And we're done. We just found out how to solve this problem and what skills you need to do that. Thanks for watching. If you have any questions, please comment below.